Welcome to the deep dive. Today we're plunging into something, well, maybe surprising, an ancient force that could be the future of energy storage.
Gravity.
Exactly, gravity. That thing keeping our feet on the ground, now being engineered to power our grids. We're talking gravity storage. It sounds almost too simple, doesn't it?
In a way, the core concept is simple. Gravitational potential energy.
Right. But how are we turning something so basic into, a cutting-edge energy solution for today?
Absolutely. It's like, think about riding a bike downhill.
Okay.
That feeling of coasting, that stored gravitational energy converting into motion. Gravity storage is kind of like that, but engineered.
So instead of a bike?
Instead of a bike, we're lifting massive, really dense objects using surplus electricity, often from renewables like solar or wind when they're producing more than needed.
Right, storing that excess.
Exactly. And then when you need the energy back, you let the objects descend. Gravity does the work, turning a generator and converting that stored potential energy back into electricity.
So it's like a giant mechanical battery made of rocks or concrete blocks.
Pretty much a super durable one. And what's fascinating here is the why now.
Yeah, why is this taking off now?
Well, the basic idea isn't brand new. It's been around conceptually for a long time, decades, even centuries in different forms. But it's only recently gained, serious traction. This approach is becoming crucial for storing that surplus energy, especially from variable renewables.
The solar and wind problem, storing it when it's made, using it later.
Precisely. As we add more renewables, we need ways to store that power for when the sun isn't shining or the wind isn't blowing. Gravity storage helps stabilize the grid, makes it more robust.
Okay, let's unpack this then.
Yeah, this deep dive will look at its evolution, the really cutting-edge designs now, and what it might mean for you and our energy future.
That's a great point about the why now. Simple ideas, refined by modern tech, suddenly very powerful. So looking at what kind of approaches are we actually seeing?
Oh, it's quite diverse. One really prominent example is Energy Vault's system. They've got one running in Rudong, China.
What does that look like?
Imagine a huge tower, almost like a giant automated crane system. It lifts and stacks these massive multi-ton concrete blocks.
Stacking them high up.
Right, storing energy. Then, when power is needed, it automatically unstacks them, letting gravity pull them down to drive generators. It's basically a huge kinetic battery, but above ground.
That's quite a visual. And then there's the opposite approach, going underground.
Exactly. That's also gaining momentum. Companies like Gravitricity and Green Gravity, they're focusing on repurposing old, abandoned mine shafts.
Using existing holes in the ground. Clever.
Very. Instead of building big towers, they drop enormous weights down these shafts using winches. Then they winch them back up to store energy.
Less impact on the surface, I guess. And maybe cheaper.
Potentially, yeah. It reduces land use, can lower capital costs, and, gives a new purpose to these old industrial sites. We're also seeing other ideas like conceptual underground piston systems using water pressure. Wow.
To lift and lower huge weights in sealed caverns. The ingenuity is pretty remarkable, tuning basic physics into something quite advanced.
Thinking outside the box, or maybe inside the mine shaft. So beyond the clever engineering, what are the real killer advantages here? Why choose this?
The core advantages are pretty striking. First off, lifespan. These things are built to last. We're talking 50 years, maybe more.
50. Compared to batteries,
which degrade over time, right? They lose capacity. Gravity. Well, gravity doesn't degrade. It's constant.
Makes sense.
And once they're built, their operational emissions are incredibly low.
Yeah.
Very green in operation.
And you mentioned materials earlier. Using waste.
Precisely. That's another fascinating angle. The potential to use really abundant local materials for the weights. Things like construction debris, mine tailings.
So turning trash into energy storage.
Kind of, yeah. It really supports a circular economy idea. Of course, it's not perfect. There are hurdles.
Like what?
The main one is the high initial construction cost, the CapEx. It's a big upfront investment. Building these massive structures or prepping mine shafts isn't cheap.
No. And for the surface systems, like the towers, there can be land use concerns or visual impact, especially near populated areas. But people are working on modular designs, integrating them better, trying to mitigate those issues.
Okay, so putting it all together, where does gravity storage fit in the bigger energy picture? How does it stack up against, say, lithium-ion batteries?
Right, connecting it to the bigger picture. It's really about being a complementary solution. We looked at this using our Will It Change Everything index. Gravity storage scored a 59.5. That's really competitive, almost matching lithium-ion, which is around 60.
Wow, neck and neck.
But here's the key difference. Gravity storage really shines for large-scale, long-duration storage, storing huge amounts of energy for potentially days or even weeks.
Whereas batteries are maybe better for faster response, shorter bursts.
Generally, yes. Batteries are great for grid frequency, quick power needs. Gravity systems are more about storing bulk energy for longer periods, so they're powerful partners. You need a mix of technologies for a truly resilient grid.
So as we shift more and more towards renewables, this ancient force, gravity, it could literally be holding our energy future steady.
It's a really intriguing possibility, isn't it, using the planet's own pull?
Definitely something to think about. As the world keeps changing, what fundamental role might gravity play in keeping our grid stable, keeping the lights on, maybe transforming how we even think about power?
A fundamental force for a fundamental need.
Keep digging, and we'll see you on the next deep dive.